Today I'll be presenting MAXVY MIPI DSI-2 Tx IP, which is basically a display serial interface to transmitter with high performance and low display interface solutions for modern and advanced SoCs and as well as display systems. I'm uh, I'm Raghu BK, and this session I will explain the architecture capabilities and FPGA validation of this IP. Yes, let's go on. In today's session, we will cover the modern display system challenges, what is MAXVY MIPI DSI-2 Tx IP is, the protocol overview, the internal architecture, baptized video format, the PHY layer integration, key specifications, FPGA prototypings, and target applications, as well as the resource deliverables, and why MAXVY at last. So let's start over. So the display panel evaluation or hardware panel evaluation. To evaluate the MAXVY DSI-2 Tx IP, we implemented the system on AMD Zinc UltraScale Plus ZCU102 board, which the setup includes a MIPI FMC card, which converts the FPGA interface into a MIPI DSI-2 interface through an adapter board. The transmitter IP is connected to a AU Aptronics B101 UAN 10.7 display panel. So these setups allow us to validate the real-time transmission of display data from FPGA to the display panel. So let's move on. So the hardware setup. The hardware setup, as I told you, the display panel is used AUO 101 UN 01.4. Basically, it's a TFT LCD display, and its resolution goes from 1920 into 100. WUXCA supports, and also 16.7 million colors, which uses a 4-lane MIPI DSI2 interface. And when it comes to a system operates, which can operate at 148.2 pixel for clock, as well as 60 hertz of refresh rate, and the horizontal and vertical axis from 1920 active plus 120 backing, and 1200 active plus 12 banking. And in the validation scope, we have verified functionally and performance as well as reliability of MAXVY DSI2 TX subsystems, which can support high HS, high performance, LP, the low power as well as ultra low power transitions, lane DSQ, short or long format processing, as well as the correct frame updates. Okay, then let's move on to the next generation display challenges, which currently the
வந்து எடுத்துக்க boss. பாடம்
sorry, is there any interruption?
Sorry.
Yeah, okay. Yeah, let's move on then. So these are a modern display system face several major challenges. The first one is the bandwidth scaling. So since UHD displays require extremely high rate data, so the second one is a protocol optimization, where a DSI2 improves efficiency as well and removes congestions. And third is a latency, which is critical for AR or VR automotive safety systems. And the fourth is the power consumption, where the features like the ultra low power, what we say, which helps the balance of the performance as well as the energy usage. And the final one is the interoperability, which standards the protocols enable cross industry complications. So these are the modern display systems, which includes bandwidth protocol, latency, and power subsystems. Let's move on to the next. So yeah, what is MAXVY MIPI DSI2 Tx IP? So it's a cutting edge technology. Cutting edge transmitter code designed, which for next generation display systems. It supports resolutions from full HD up to 4K with HDR capability. The IP enables high speed, low latency transmission of both video as well as a command data, with speeds up to 10 Gbps per across lanes. And then it's a FPGA proven and designed for both ASIC as well as a FPGA integration, making it scalable for mobile, automotive, and industrial applications. MAXVY is also a member of MIPI Alliance, ensuring full compliance with industry standards. Then let's go for the protocol overview. So the MIPI DSI2 protocol uses a layered architecture for efficient high-speed communication. The architecture includes 4 layers basically. The first one is application layer, which includes display interfaces like TPI2 and DBI2, which is a pixel and byte interface basically. And the next one is a protocol layer, which is responsible for packetized data formatting. And then the low power protocol layer, which ensures a reliable error-free transmission. And the last one, the PHY layer, which handles the physical signaling using D physical interfaces. So this architecture enables high-speed display communications with fewer pins, which compared to the old version interfaces. And these are the protocol overviews which have been applied in the MAXVY DPI to protocol overviews. And let's move on. So it is the architecture of the MAXVY DSI-2 Tx IP. As you can see the block diagram here, it includes PHP, Lite, PPA, and these AMBA interfaces. The FIFO controller, the DSI2 controller, which is a top module, ERCA basically for error detection, this packet encoder, the lane distributor, it's a FSM logics, and also a pixel to byte converter. So let's move on and let's handle this one by one. Well, top level integration. So, which is a unified DS2 subsystem, which integrating control, video input, protocol processing, lane management, and PHY connectivity, which have been overall included in the top level integration. The next one, the processor interface. In here, the interface supports AHP Lite, APB, and AXI, which are standard host control interface with programmable register map for mode, timing, as well as a status. The FIFO controllers basically acts as a buffer data between the systems and the protocol layer to ensure a smooth, continuous, and transmission. And the pixel to byte converter, which basically converts the incoming pixel data into a byte streams, which is required for the DSI packetization. Yeah, DSI2 packet encoder. So it basically generates a MIPI compliant short and long packets for both command as well as a video mode, as our MIPI DSI2 supports both command and video mode. And for error generation, we do have ECC and ERC generators, which provide headers ECC for payload and CRC for a reliable error protected data transfer. For the lane distributor, stripes byte data across configurable D physical lanes for scalable bandwidth, and FSM logic. So it controls the protocol sequencing, basically low power or high speed mode transmissions, and the physical handshaking. So physical interface. So here the standard interface to D physical for high speed specialized transmission, which helps for the display handling. So overall control interfaces include video input processing, protocol handling, lane management, and physical layer compatibility. Let's move on. So packetized video transfer. So here in DSI2 video data is transmitted in packetized format. So packet types includes video packets as well as a command packets. As you can see here, we have the data efficiency and corrections in our image. Just a minute. Yeah, and the packet which have a different transaction modes, which can include non-burst mode, the burst mode, and the command mode. The system which basically converts RGB or YUV pixel data into a byte stream and distributes them across lanes for efficiency as well as high-speed transmissions. So the DSI2 TIP serializes the AXI stream, the what the input is connected, that is RGB 88 into a DSI2 packets over D physical layer, which can support 1 to 4 lane and up to 2.5 Gbps per lane. So basically, we had to have 4 lanes. That for 2.5 into 4, it can support overall 10 Gbps. Let's move on. So the physical layer integration. The physical layer manages the physical signal and transmission. The system supports 1 clock lane and 1 to 4 data lanes with up to speed 2.5 Gbps per lane for different display resolutions as well as the cost-effective designs. And for the signal integrity, it do support free lane DSKU, jitter tolerance, and forwarded clock BR, which is a BR optimized. And for timing and covers, it supports high speed, low power, ultra low power systems, transitions, and PLL or CDC stability for the dynamic gating for low latency response in a real time display bus. For layout and compliance, the EMI imitations, PPI handshakes, and BIST supports, which are verified on a FPGA board. And for future proofing, it supports MIPI compilant, ERC or ECC, and DCN for automotive grade robustness of error detection. So let's move on, and here the main part, as we specify the key specifications of the MIPI of the MAXVY DSI-2 Tx, which is a fully compliant with the MIPI DSI-2, which is the latest version 2.0 standards, as well as it supports physical layer of up to D physical up to a version 3.2 and C physical up to version 2.0, can support 1 to 4 lanes, which has a wide PPI interface for physical handoff. The transmission modes, which support high speed and low power states with a short or long MIPI packets, including synchronization and event packets. The data formats, it can support RGB up to from 565 to up to 888, the YUV, and also it performs pixel to byte conversion, scrambling for payloads or footers. For error handling, it headers ECC and payload CRC for protocol level error detection. And the power management, so it does include the ultra power scale entry or exit, ultra low power entry or exit, high speed low power packet transaction or reception. And for the debug and test, programmable test generator integration debug support. As for the interfaces, it can support up to 32-bit AMBA ABP slave registers, as well as it can support AHP Lite, ABP, or AXI processor configurations. For the precision modes, the programmable latency for video timing accuracy. And for the input options, we do have DPI, DBI interfaces, and the seamless AXI stream integration. So these are the power total LUTs, total area, and the total cells, which has been concluded in the DSI protocols. So the power is up to 500, and the total LUT count 3175. The logic LUT count 3075. The total area it's 69661.48, and the total cells 81.890. Yeah, so let's move on. So yeah, as I have told you already, the MAXVY IP is a FPGA proven IP. So it has successfully implemented and validated its IP cores on FPGA boards, which have also demonstrating proven real-time performance and also full protocol compliance. So these hardware level verifications ensure FPGA ready reliability, faster integration cycles, and reduced development risk for customers. And coming to MAXVY DSI-2, which is the latest version 2.0 Tx IP, it's a production ready excellence, have implemented on the ZCU FPGA, and it's a FPGA proven, which have 3.1K LUT and can support up to 4K resolution at 60 FPS. And the full MIPI version 2 stacks, which supports D physical layer, where up to a latest version of version 3.0 can support up to 2.5 Gbps per 4 lanes, and burst or video modes. So some mission creatability for ECC or ERC for error detection, can support ULPS and low frame drops. For SoC instant integrations, we have AXI or AVP or AHV integration configurations, and can support RGB created VDMA native. So here is the link. It's a full live real-time demonstration. It's a real-time video it's a real-time video image capture processing, as well as the display system. So here the link, you can see it, and it's a product. Basically, this product includes DSI-2 IP, which have been implemented in in the FPGA board. So yeah, let's move on. So here are the target applications where the MIPI DSI-2 can be applicable. So this IP can be used in a wide range of applications, including high resolution mobile display systems, automotive, informative, and display cockpits, instrument clusters and HUDs, embedded systems, AR and VR devices, wearable and portable systems, medical imaging systems, as well as IoT and sensor devices. So let's come to our resource deliverables. So when customer license this IP, MAXVY provides a complete integration toolkit, which includes a synthesizable Verilog source code, comprehensive and compressed user and IP integration guide, automated run and synthesizer script. So we do provide encrypted verification test bench environment with protocol checkups and coverages, compliance and interoperability test reports, as well as the technical support and the integration collateral. This ensures smooth integration and a faster product development. Yeah. So let's come to why MAXV. So MAXV has 9 years of experience in a high-speed interface IP developments, and we do have our IP solutions are FPGA proven, scalable, and optimized for performance and reliability. With a strong, and also we do have custom engineered IP which are scalable, application optimized solutions aligned to your exact specifications, accelerated time to market, FPGA prototyping, complete documentation, and hands-on technical support, and trusted industry player, as we are a proud indigenous as well as a MIPI Alliance member, driving end-to-end semiconductor innovation from the Bangalore. So with strong documentation and technical support, MAXV helps customer accelerate their time to market. So MAXV works with multiple semiconductor companies and technological partners, delivering reliable IP solutions for advanced system designs. And these are the clients of MAXV Technologies Private Limited. Yeah, that's it. Thank you so much for that. Here I conclude my presentation. Thank you for your time and attention, and I'm happy to answer any questions.